All right, so in this video we're going to look at another side of the fundamental theorem of algebra. So the question we're going to answer is how to write the standard form of a parabola, or it could be another polynomial, a cubic, or even 1 to the 4th power, if you're given the roots. So there's one way that they might give you the roots, and that's through a picture. And so if you recall, the roots are just the x-intercepts. So here we have an x-intercept of 2, and here we have an x-intercept of 4. So what I'm going to go through is I have to think about the parentheses that would have given me that picture, and the parentheses that would have done that would have been x minus 2 and x minus 4. So I put the y equals in front because I'm writing the equation of something. You could also put f of x in front. Either one of those would be fine. Now, if the directions had said find the linear factorizations, so the factors, we would be done. This problem would be finished. But they didn't say that. They said standard form, which means we have to multiply these parentheses out and see what the parabola actually is. So I'm going to go ahead and FOIL. X times x is x squared. X times negative 4 is negative 4x. Negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8. And then I'm going to go ahead and combine my like terms. And put my y equals in front because it's the equation of a parabola. And I'm completely finished. All right, on the next one, first we're going to look at each of the roots that we have. We've got one here that's at x equals negative 1, and so in my parentheses I would have an x plus 1 right there. And then over here, that would be at x equals positive 3, and so that would be x minus 3. And because of the shape of that root, we should notice that it would be squared, because that root has a multiplicity of 2. The x minus 3 must have happened twice. So if I was to write this problem out using the linear factorizations to start with, I would say y equals x plus 1 and x minus 3 squared. And then I have to look at my end behavior on this, so you can see that my first arrow goes up, my second arrow goes down, and so that means that overall this is a negative graph, and so I have to have a negative in front of my parentheses. So if it said linear factorizations, we would be done. But because it says standard form, we're not finished. We actually have to do all the multiplying out on this. So I'm going to rewrite the problem and make sure that I know all of the parentheses that I have so that I know what I need to multiply. So I have 2 of the x minus 3's in parentheses. So to multiply 3 different sets of parentheses together, you just have to choose 2 to start with and multiply those 2. And honestly, it does not matter which 2 you choose to start with. So I'm going to go ahead and just multiply these 2 because they were on the left. So I've got x squared minus 3x plus x minus 3. I'm going to go ahead and put those together. X squared minus 2x minus 3. And then I'm going to drop down the rest of the problem so that I still have everything that I had before. All right, now I'm going to multiply these 2 sets of parentheses. And most students, when they start to FOIL, and now we have something with 3 in it multiplied by something with 2 in it, that can be kind of hard to FOIL. And so I encourage students typically to multiply this sort of thing with a box. I'm going to draw a 2 by 3 box because I have 2 pieces, the x and the negative 3, multiplied by 3 pieces, which is x squared, negative 2x, and negative 3. So that's x to the 3rd, negative 2x squared. So what I did is I was just multiplying this one times that one. It's kind of like a multiplication chart. Negative 3 times x is negative 3x. X squared times negative 3 would be negative 3x squared. Negative 2x times negative 3 is 6x. Negative 3 times negative 3 is 9. So I have x to the 3rd minus 5x squared plus 3x plus 9. And then I'm going to drop down everything else that I had. So now I just have to fix with that negative and distribute the negative through to everything. And my final answer would be y equals negative x to the 3rd plus 5x squared minus 3x minus 9. All right, and one last picture for us. We have 4 roots here, or 4 zeros. So we've got this one, that would be x plus 5 in the parentheses. Here would be x plus 1 in the parentheses. And then we would have x minus 3. And last we would have x minus 4. So y equals x plus 5, x plus 1, x minus 3, x minus 4. So overall, this polynomial is going to have a degree of 4. And if I look at it, both of the arrows go up, which means that this overall is a positive polynomial. So I don't have to put a minus in the front. All right, so again, if they wanted linear factorizations, we would be done, but that's not what they want. They want standard form. So I'm going to go ahead and multiply these two parentheses first. So I get x squared plus x plus 5x plus 5. And if I combine my like terms, that's what I would get. And then I can also just multiply these last two parentheses together, and that will save me a little bit of time, so I don't have to like get something bigger and bigger. Multiply things one at a time. So x times x is x squared, negative 4x, negative 3x, positive 12. So go ahead and put that in parentheses. So this is x squared minus 7x plus 12. And then I'll drop down the y equals because that's all I have. So now to multiply my blue parentheses times my green parentheses, I'm going to have 3 pieces times 3 pieces. And so I'll go ahead and make a box that is 3 by 3. So x squared, 6x, 5, and it does not matter what you put on which side as long as you have all of the pieces. You'll get the same answer anyway. So x squared times x squared is x to the 4th, negative 7x to the 3rd, 12x squared, 6x to the 3rd, negative 42x squared, 72x, 5x squared, negative 35x, and then 60. All right, so at the end I have y equals, and then I can just put my like terms together. So I have x to the 4th, negative 1x to the 3rd, negative 25x squared, positive 37x, and 60 on the end. I did all that math in my head, so hopefully it didn't go wrong. All right, now sometimes the answers are not nice whole numbers like that, and so the thing that we want to consider here is what kind of answers we get when we solve for x with the quadratic formula. So if you remember, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. There's the quadratic formula. And anytime we did the quadratic formula, we always got 2 different answers. We got one answer for the plus version and one answer for the minus version. And in particular, anytime we had a number underneath the square root sign, then that would give us 2 answers. We might have 1 plus or minus the square root of 3 over 5. And so the 2 answers would have been 1 plus the square root of 3 over 5 and 1 minus the square root of 3 over 5. Those numbers always came in pairs. So whenever we deal, or if, let me backtrack, let's say we had 3 plus or minus the square root of 4, negative 4, and so you took out the negative 4, and then you put a little I in the front, and let's say that was over 7. So again, we would have 2 answers there. We would have 3 plus, and square root of 4 is 2, so it'd be 2i. 3 plus 2i over 7, and you would have 3 minus 2i over 7. So anytime we had a radical in the answer or an I in the answer, any of that stuff, we always had 2 answers, one with a plus, one with a minus. So always have a plus, minus, 2 answers. So the next example is still a picture, and it's showing you what would happen if you had 2 different solutions, one for x equals square root 2, one for x equals negative square root 2. So for this, we're going to write our parentheses just like we normally would. So this parenthesis right here would be x plus square root 2, and this parenthesis over here would be x minus square root 2. And so I'm going to go ahead and start writing for my parabola. Y equals x plus square root 2, x minus square root 2. And then they want the equation in standard form, and so we have to FOIL that. So x times x is x squared. X times negative square root 2 would just be negative square root 2x. So just like any normal number, when you multiply it by x, that number just goes right in front of it. It becomes the coefficient. So positive square root 2 times x would be positive root 2x. And then the tricky part is when you multiply positive root 2 times negative square root 2. And that would just look like this on your calculator. So you can see that when you multiply those numbers together, you just get negative 2. So anytime you're doing something like that in a problem, don't even worry about it. Even though it looks weird, you can just type it into your calculator. Oh, 2. All right, so then if we simplify the problem, I'm going to drop down my y equals. If we simplify the problem, you'll see that these two things are opposite signs, so they actually cancel out. And so your final answer would be y equals x squared minus 2. All right, for the next couple of problems, they don't give us a picture, they just give us the words, so we have to figure out what they're saying. So it says, find the standard form of the equation of a second degree polynomial, so a quadratic or a parabola, where one of the roots is 3i. So here they're telling you, sorry, negative 3i. So here they're telling you x equals negative 3i. And they only give you one of those. And because it's second degree, we know that there must be two things that x equals. And it's easy to figure out what it is because the i's and the square roots always come in pairs. So if you had negative 3i as an answer, you also have to have positive 3i as an answer. So now that I know one of my x equals negative 3i and the other one is positive 3i, I can go ahead and write out my linear factorization part of it. And so for the first parenthesis, this one would be x plus 3i. And the other one would be x minus 3i. And now I just need to FOIL. So x squared, x times negative 3i, again, anytime you have a number, you just put it in front of the x. So negative 3ix, 3i times x is positive 3ix. And then 3i times negative 3i would be negative 9i squared. And if you guys remember, I squared actually is negative 1. And so on the end, this is basically negative 9 times negative 1, which is positive 9. So I'm going to scribble this out, but that's a positive 9 right there. And then I'll drop down my y. So now I can simplify the problem. That's a y, not an x. Y equals x squared. These two cancel out because they're opposite signs, and then we just have the positive 9 on the end. All right, we'll do one more so we don't make the video too terribly long. Find the standard form of the equation of a third degree polynomial. That means I'm going to need 3 sets of parentheses. With the roots negative 2 with a multiplicity of 2. So x equals negative 2. To have a multiplicity of 2, that means that for that parenthesis, we're going to square that number. Or it means that we got the answer x equals negative 2 twice. That's what multiplicity means. And we have the answer 1 with a multiplicity of 1. So x also equals 1. So for the first one, this is x plus 2, x plus 2, and then x equals positive 1 would be x minus 1. And again, y equals that stuff. So you could write in the beginning x plus 2 squared if you wanted because of that multiplicity of 2. But you're just going to have to write it out as 3 of them anyway because we do need to multiply these all together to put them in the standard form. So I'll go ahead and multiply the first two. I've got x times x is x squared plus 2x plus 2x plus 4. So that gives me x squared plus 4x plus 4. And then I'll drop down everything else. And so now to get my final answer, I just need to multiply the rest of it together. So I have 3 pieces multiplied by 2 pieces, So I'm going to make my box so that I can multiply those things easily. X squared, 4x, 4. So x to the third, 4x squared, 4x, negative x squared, negative 4x, and negative 4. So my final answer would be y equals x to the third plus 3x squared. Those cancel out, so I don't even have to write it, and then a negative 4 on the end.